Hey everybody. In this video, what we will do is to construct a portfolio consisting of 12 bonds. We will value the portfolio by valuing individual bonds making up that portfolio, and then change the interest rates up or down, doesn't matter, and see how the value of the portfolio will be affected by that change in interest rates. All right, so what I did is listed the bonds like this in vertical columns, and you can see the features of each of these bonds. So consider a financial portfolio manager which owns the following number of these bonds, right? So bond 1, he owns 120 pieces of bond 1, 100 units of bond 2, and so on, 75 units of bond 3, and so on. So these bonds, bond 1 has an 8% required rate of return, 3 years to maturity, payments are $70 coupon payments, and the face value of the bond is $1,000. First order of business will be to calculate the value of the bond, and once we multiply the value of the bond with the number of bonds we are holding, it will give us total amount invested in that bond, in that type of asset category. So this will be equal to the present value of, well, the rate, the required rate of return, the number of periods. Each of these bonds are annual, so we don't have to worry about compounding, and finally future value. Boom. So that's the value of the bond. Actually, because I don't want to see minus signs, so I will just go ahead and put a minus at the front. All right, so there you go. So the minus means this is the amount that you had to invest, right? So that's all right. And I can just go ahead and drag that formula, copy paste it all the way here. Awesome. So I think I need more space there. So let's just add a little bit space. How about that? Okay, wow, it's way too much. Maybe a bit less. Awesome. Now, what is the total amount invested in each security? Well, it's just the number of those securities that you own times the value of each security. So our investor or the portfolio manager is invested about $116,000 in bond ones, right? So he owns 120 units of those bonds. Each one is worth this much. The same thing for bond 2. So it's equal to this number times this number. So you guys see what's going to happen, right? So we can just go ahead and just copy all the way here. So here inside the bond portfolio value, what I did is just to add up all these numbers. Why the minus? I think I added an additional minus there, which I don't need. There you go. So this is the value of our portfolio as of now. So tonight you went home, the next morning you came back to work, and you just realized that the change in rates, you realize that across the board, the interest rates went up. All right, so let's just say, for instance, they went up by 0.1%. So this is a fraction, 1/10 of 1%, a tiny fraction. For instance, this bond for which the required rate of return was 8%, now the required rate of return for that bond is 8.1%, a tiny bit change. Let me just go ahead and so I can see the value of the portfolio as well. Let me make it, okay, there you go. I can still see the value of the portfolio. So if this change happened across the board, then the question is, how will my portfolio be affected by that change, right? So there's a couple of different ways, but obviously we want to make use of duration. So remember how we used to calculate duration just for a minute. So suppose that I want to calculate duration. Well, the way we calculate duration is we construct a table, the time period, the cash flows, the discount factor, discounted cash flows, and the time. For instance, let's have a look at the first bond. So 3 years to maturity, so 1, 2, 3. The cash flows will be $70 for year 1 and For year 1 and 2, it will be $70. For the maturity, you will also receive an additional $1,000. So in total, it will be $1,070. So the discount factors will be 1 divided by 1 plus the rate, which is in this case, it's this amount. I want to fix it. and we want to raise it to the power of number of periods. Now notice that whenever it's semi-annual, we have to multiply the exponent by 2, but not in this case because all these bonds are annual coupon paying bonds. That's it. So we can just carry it down like that. And finally, this one will be just the product of uh, uh, the cash flows times the discounted cash flows, right? Yes, these amounts. And then I can click it down. Finally, last column, T times DCF, discounted cash flows, which is because we want to find a weighted average time to maturity, right? So this number times this number. That's it. Double click. So we come up with the sums. So this number is just the sum of all these numbers. If we are lucky, remember the denominator. This will end up being the denominator. That better be equal to this bond value. We learned about that. 974.22. Yes, it works. And then the sum of this column over here, which is this number. Now, finally, duration is equal to just this number divided by that number. Awesome. Now, the problem that we're having is we need to carry that number. So this number is equal to simply this number, but we need to repeat the calculation, like 10 times, right? So that's the problem we are having. Do we want to construct this table 10 times? The reason I'm saying that is, why don't we just overwrite the numbers? We can't, because each of these bonds have different maturities, right? So the shape of the tables will be different. So it will be very difficult to model it. Does that make sense? So as a result, either we need to write the formula inside of it, or the good news, Excel has a built-in function for duration. But first we need to understand that built-in function. So let me just make sure we understand the built-in function. So Excel duration function. So check this out. So if you go to formulas ribbon and go to financial, and here you will have the duration formula. So it will ask for settlement date and maturity date. The rest is the same. So coupon rate and the rate, the actual rate, the required rate of return, and the frequency is annual. So these other numbers are easy, but settlement and maturity is curious. So what I will do is the following. So let's write them down. So we need a settlement. We need maturity date. Maturity date. This one was also a date, right? So date. And then the rest is the same. So coupon rate, the actual rate, required rate of return, and finally whether it's annual or not. If it's annual, we just put a 1 basically. But first, the settlement date. So let me just go ahead and put a settlement date of January 1st, 2020. All right. So the maturity date for the first bond will be 3 years from today, because it's a 3-year bond. So I need to find a way to write 3 years after this. So for instance, if I say this number plus 3, what it will do is it will add 3 days to it. That's not what I want. I want to add 3 years to it. So there's a little bit a tricky way to do it. It's a little bit bashy, but it works. So let me show you how to do it. So you write date, the year. So the year of that date that you want to try is the year of this one plus 3, right? So it will be year, use the year function. This cell, close parenthesis, plus 3. You want to add 3 to the year there. How about the month that I want to use? That one is easy. The month is just the same month as this one. Close parenthesis, comma, and then the day function. The day will be the same day as this one. Does that make sense? So what I did is I just added 3 to the year of this cell. The month and the day is remaining unchanged. Press enter, and there you go. January 1st, 2023. Does that make sense? So and then now the coupon rate. The coupon rate is just the coupon payment divided by the face value. So we need a percentage for the rate. All right. So coupon rate as a percentage, There you go. The required rate of return is simply equal to this number over here. That's it. We are ready to calculate the Excel duration function. So we just write duration, and it's asking for a settlement date, which is this date, the maturity date, which is this date, the coupon rate, which is this, 7% basically, the yield, which is this, and finally the frequency. It's annual, right? So I just double click this or just select this one, doesn't matter. All right, it's always 1 in our case. That's it. Hey, look at that. We got the same. So this whole table basically gives us the same answer as the Excel function. So what I will do is I will just go ahead and delete all this table. I want to directly use the Excel duration formula, right? So just delete this, carry that cell over there. So let's just go ahead and carry that over here. We no longer need this. We need to carry all this up. There you go. Now, final thing is we need to do it 10 times, but that will be easy. So what I can do is I want to make sure that for every bond, it starts at January 1st, 2020. Now I can just drag my formula all the way for 12 times. And the maturity date, because I have my everything is the only thing worried is the 3 years. Let me just change that. I don't want really 3 years, but I want to point it right here. So each time it will update automatically. Does that make sense? So now let's try to double click. Oops, click the wrong way. I want it horizontal. Let's see if it works. For instance, this bond will mature in 2023 as well. Yes, that's a 3-year bond. This one will mature in 2024. Yes. 2026. Why? Because it's a 6-year bond. The starting date, I just made up that date, January 1st, 2020, and added 3 years to the bond. So therefore, I have the maturity date as a result. Okay, so the coupon rate, all these are the same basically, right? All we want is just to carry them over here. We don't even need the annual. It's always annual, so this is not a problem. All I now do is just to let me make sure everything is, yes. Look, all these cells are selected. So therefore, if I were to extend it, let's see the second one, if it works properly. Yes, it's selecting the correct cells. Do you guys see that? So these are the durations of individual bonds, right? Now we are ready to value, so to see the effect of this change in interest rates. How will it affect the value of my portfolio? So the change in value, well, we will do the change in value of individual bonds, and then we will add them up to find the change in overall value. Change in value of portfolio. Does that make sense? So this one will be the change in value of the portfolio versus the other ones is the change in value of individual bonds, right? So let me also click that. All right. So, and let me also go ahead and highlight this as well. Oops. I think I didn't want it to color this one, right? There you go. So let's go inside. I want that text to be above it. Control D. There you go. All right. And obviously, when I add the value of the portfolio plus the change in the value, will give me the final value of the portfolio. New value of the portfolio. I can call it new value of portfolio. Does that make sense? As a result of a change in interest rates. Interest rates go up tiny bit. How does the value of my portfolio change? Interest rates go down a little bit. How does the value of my portfolio change, and so on? Okay, so the change in the value of amount invested in the bonds, well, that will be just simply equal to minus, because they will be going in opposite directions, minus the duration times the value of the portfolio times the change in rates, this number, divided by open parentheses 1 plus the rate. That's it. That's it. So the only thing that I need to fix is really the change in rates. So let me press F4 for that. All the rest should be variable, right? As I drag it towards the right, it should be useful. Let me see if it works. Perfect. Now notice that when the rates go up, the value of individual bonds go down. Perfect. So therefore, the overall value, the sum of all these numbers, Press enter. $8,594 decline in the value of the bond, so of the overall portfolio, which consists of these 12 bonds, right? So therefore the new value of the portfolio will be this number. So the next day, when you go to the office, you thought that you are managing a portfolio which was worth 1.194015.91 million, so $1.1 million, or close to $1.2 million. Now the value has declined by $8,600 almost. So a tiny bit change. So this is 1/10 of 1% change in interest rates. Usually, whenever the Federal Reserve has open market meetings, it is the rate changes are about 25 basis points. This one is 10 basis point, right? So this is 10 basis point change. So this will be 2.5 times bigger than that. And by the way, the portfolio that we are managing, a pretty small portfolio, $1.2 million is nothing. If you start as a broker at any investment bank, the starting, like as a rookie, the starting portfolio that we will be managing will be about $20 million. So in a $20 million portfolio, which is roughly 20 times what this number is, the change in the portfolio value will be 20 times 8,600, say 10,000. So on a daily basis, your portfolio will be fluctuating about $250,000 on any given day, right? So that's amazing. And every 6 weeks, it will be 25 basis points change, which is close to $1 million. Can you imagine that? Next morning you go to work, suddenly the value of your portfolio is either $1 million higher or $1 million smaller. All right. I wanted to add one more thing, verification. How can I verify that my calculations are correct? Well, you know what I can do? I can reproduce this with the correct values. Let's see how far off we are, because ultimately it's an approximation, which what we did, right? So press enter. There you go. So, oh shoot, I just deleted this by mistake. Let me just Control X. Okay, let's rewrite this value. Control C. All right, so the value is equal to this number plus that number. All right, well, this is the new value. So what we could have done is the following. So we have a portfolio which consists of all these bonds, and these are the quantities of each bond in that portfolio. The only change that I want to make is the rates. The new rates will be 0.10% higher than the old ones, right? So this number should rather be this number plus that 0.1%, except that I want to fix that number. All right, and now I can just go ahead and drag this all the way to the right. So all of these interest rates went up by 0.1%. As you can see, this one was 6% and this one is 6.1%. And suddenly, guess what? The table automatically updates. So you guys can see these changes. And as a result, the value, hey, that's the true value of the portfolio. This is true value. True value. Versus this one was an approximate value. Oops. Approximate. So how close are we? Well, the difference will tell us. The difference is about $40 as a percent difference. So the reason I'm doing that is, are we justified to use duration? Well, if it simplifies the calculations, yes. And if when we simplify the calculations, if we are not making a big mistake, we are perfectly fine. The gap here is about $40, but as a percentage, the gap is the following. So all you do is you can just take the ratio of the two, for instance, the actual value divided by the approximate value, and if you subtract 1 from that, that will tell you that it is let me write this as a percent. Actually, even as a percent, it's difficult to judge what it is. It's very close to 0%. So the error margin that we did is 4 in 1,000 of a single percent. It's tiny. So $40 in a $1 million portfolio is negligible. So the error term is so tiny, it kind of justifies, we are kind of justified to use duration. In this example, it's kind of awkward because the actual updating the value of this portfolio, it wasn't that bad to calculate the true value. One might wonder, why did we go through all the struggle to come up with an approximate value when the actual calculation is easy? Well, the reason is, in real life, it turns out that whenever you want immunization, risk management, you cannot do risk management with this because this is your starting point here. How did you know that these values were the correct values to hold, right? Why are you holding 45 units of bond for? Why are you not only holding 40 units? So what you need is you need to set up the model based on the durations, right? So something which is a little bit more advanced that we usually teach our students in the Masters in Finance program in upcoming courses in the program, something called the fixed income securities. That course, I think it's Finance 8304. So you can learn more about those in that course. How do you model the actual model so that demand meets supply, in the sense that you have clients. Suppose you're an insurance company, you have clients, and in order to meet the policy amounts in those policies, how do you match those with building a portfolio that suits their needs, right? Yeah, so for that purpose, that will be very, very useful. So what we did in this video was to construct for a given portfolio, we learned how to value the portfolio. After that, we learned how, by using duration, and on the way we also learned a new duration formula that Excel has a built-in, except that we needed to make a tweak in the system to make it work. We were able to approximate the change in value of the portfolio given a change in interest rates. For instance, now I can easily update the formula. What if this was a downward? What if the interest rates went down by 0.25%, right? Suddenly you see how the value of your portfolio goes up by $21,000. That's amazing. So that's the approximate value, and that's the true value. Again, the two numbers are very close to each other, and the error term is a little bit higher, but still very manageable, right? The error term will be, like in this example, it's 1/10 of the change in rates, which is, the change in rates is already pretty small, right? Interest rates, they don't change too much on a daily basis. Awesome. So hope you guys enjoyed that, and looking forward to see you guys in our next video.